Hi, so I'm going to go through question 7 on Math 2007. So in this question, we are given collections of tiles, each of which contain two strings of letters, one on the top and one on the bottom. And a match is a list of tiles from the collection we're given, which have the same string of letters on the top as on the bottom. So for example, if we were given this collection of tiles, then this would be a match because we have AABAA on the top and also AABAA on the bottom. And they do tell us that tiles may be used repeatedly. So, for example, they've used this AA over A tile twice. Okay, and now we are told to consider this set of tiles. And we are asked, what tile must a match begin with? Okay, so let's think about the start of our match. So we know for a match, we're going to need the same string of letters on the top as the bottom. And so the string on the top must begin with the same letter as the string on the bottom. And so whichever tile we choose to start our match with, the top of our tile must begin with the same letter as the bottom of our tile. And we can see that the only tile that that's true for is this one. And so this is the tile we must begin with. Okay, now for part B, they want us to write down all of the matches which use 4 tiles, counting any repetitions. Okay, so we know that our matches must begin with this tile. And we see we've got 2 U's on the top. And because we want the bottom to be the same as the top, then that means we're going to need another U to follow this one on the bottom, and so the next tile that we choose must have a U on the bottom as well. And so we see that one of these tiles must be the second tile in our match, because these are the only tiles which have U on the bottom. Okay, so first let us suppose that we have this tile followed by this one. So now we see we have UUX on the top. So for a match, we're going to want an X to follow these 2 U's on the bottom as well. So the next tile that we put down must have an X on the bottom, and we see that the only choice for that is this tile here. And now we have UUXZ on the top, so we're going to need a Z to follow this X on the bottom as well. So the only tile with a Z on the bottom is this one. So we're going to want to put that next. And we see that this indeed is a match, because we have UUXZE on the top and also on the bottom. Okay, so let's suppose now that we put this tile after our first one. Well, now we see that we have 4 U's on the top and 2 on the bottom. So we're going to want another 2 U's on the bottom. But each of these cards only have 1 U on the bottom. So we're going to need to use 2 of these cards just to balance out these U's on the top. But then we're going to be left with X's or U's or Y's on the top that we won't be able to balance out with anything on the bottom. And so we see it's not going to work if we try and start a match off like this. Okay, so now let's try using this tile as our second tile. Well, now we see we've got 2 U's and a Y on the top, so we're going to want a Y to follow these 2 U's on the bottom. And so our only choice for that is this tile here. And so now, again, we've got a Z on the top, so we're going to need a Z on the bottom. So we're going to use this tile again. And we can see that this is a match because we have UUYZE on the top and also on the bottom. So we found 2 matches, and these were the only matches which we could have had. We replace this tile with this one, so our collection looks like this now. And it asks what is the least number of tiles we can use in a match, and also number of tiles. And they give us a hint. They say that we may find it easier to construct our matches from the right going backwards to. Okay, so let's use their hint and think about how our match is going to end. So the last tile we put down, the letters on the top must end with the same letter as the letters on the bottom. And so we see that this tile would work as an end tile because we have the top ending with an E and the bottom ending with an E. The only other tile we could have ended our match with would be this one, but then that wouldn't give us the least number of tiles, because we know we start with this tile, and so we know we're going to be using one of these two tiles in order to balance out the U's on the top. Because if we just kept trying to use this tile, then that would generate more and more U's on the top. And so if we're using one of these tiles, then we're going to need one of these two tiles to balance out the X's and Y's. And if we're using these tiles, then we're going to need this one to balance the Z's. And so if we're using this tile anyway, and we can end there, then prolonging the sequence in order to end with this tile is just going to mean that we're using more tiles than is necessary, and so we won't have the least number of tiles. So we know we're going to end with this tile. Okay, and now we've got this tile on the end, we see we have 3 Z's on the bottom, and so we're going to need 3 Z's on the top to balance out these 3 Z's. And so if we want Z's on the top, we can either use this tile or this tile. Right, so for example, we might have something like this, and this would give us the 3 Z's that we needed on the top. Then now we have an XXY on the bottom, so we're going to want an XXY on the top to balance that. So we're going to have to use these two tiles to get the X's and Y's on the top. And so now we've balanced the XXY on the top, but we have U's on the bottom, so we're going to need more U's on the top, so we'll need this tile. And we see that there are only 2 U's on the top here, and we already have 3 on the bottom, so we know we're going to need more than one of these tiles. So let me put 2 down. So now we have 4 U's on the top, but we have 5 U's on the bottom, so we're going to need more of these tiles. So if I put another one down, and now after I've put this 3rd tile down, we see finally that we have 6 U's on the top and 6 on the bottom. So now the string of letters on the top is the same as the string of letters on the bottom, and so we have a match. And we know this is the match using the least number of tiles possible, because we didn't put in anything unnecessary in at any point. And so we see because there are 10 tiles here, we know that the least number of tiles a match can have is 10. Okay, so now we just need to work out how many matches there are using 10 tiles. So let's think about what we could have done differently when we were making this match in order to get a different match. Well, the only time when we had any choice of the cards that we use were when we were choosing these 3 here. We said we only needed 3 Z's on the top, so we had to use these 2 tiles. But it didn't matter which one of these I used and in which order. For example, if I'd chosen to use 3 of these, so if I'd replaced this Z over Y with this Z over X, then that would still have worked. I just need to replace this tile with X over U. And that would still give us a match if we replace these 2 tiles with these 2. So we see we have 3 cards here, and for each of these 3 cards, I could choose between 2 different tiles. So I have 2 choices for this tile, times 2 choices for this one, times 2 choices for this. And so that's 2 cubed different choices in total. So the number of matches using this least number of tiles is 2 to the 3, which is 8. Okay, and now we're given a new set of tiles. So for this tile, we have 7 X's on the top, and for this one, we have 10 X's on the bottom. And we want to know for which numbers n can we have a match with n tiles. Okay, so in a match, we know we're going to get a string of X's on the top and also a string of X's on the bottom. So let's try and compare the number of X's on the top and the bottom. Okay, so if I call this tile 1 and this one tile 2, then let's say that X is the number of tile 1s in our match and Y is the number of tile 2s. And now we know that the number of X's we get on the top will be 7x plus Y. So 7x from the X number of this tile, which have 7 X's on the top each, and the Y is from the Y number of this tile. And on the bottom, we're going to get X plus 10Y X's, because we'll get X X's from X number of this tile, and we'll have 10y from the y number of this tile, each of which have 10 x's on the bottom. And for a match, we want the number of x's on the top to be the same as the number of x's on the bottom. So we're going to want 7x plus y to be equal to x plus 10y. And that's just the same as saying we need 2x to be equal to 3y after we've simplified this down. Okay, so what does this tell us about x and y? Well, of course, 2 isn't divisible by 3, but we see 2x is some multiple of 3. And so if 2x is a multiple of 3, then we must have that x is a multiple of 3. So we can say that x is equal to 3k for k some integer. Then putting that into here, if I call this line star, then star is going to become 2 times 3k equals 3y. And now we can cancel 3 from both sides, and so we see that y is equal to 2k. So now we have that x is 3k and y is 2k, and x was just the number of tile 1s we had in our match, and y was the number of tile 2s. So the total number of tiles we have in our match is just going to be the number of tile 1s plus the number of tile 2s, i.e. x plus y. And so using that, we know that this is what x and y are. Then we see that the total number of tiles is going to be 5k. And so when it asked us for which n can we have a match with n tiles, well, we see now that it must be some multiple of 5. So we just need n to be a multiple of 5.